This is Math, Chapter 14, Lesson 10, about lines of symmetry. And in this chapter, we've talked about some different figures, triangles, quadrilaterals, and we're going to be working with some of those today, plus some other types of figures that have more sides, some of them that are strangely shaped. And we're talking about whether or not these figures have line symmetry. And so at the top of page 931 here, we've got two vocab terms that we'll be working with today, and they look pretty similar, but here's the difference here. It says a figure has line symmetry if it can be folded over a line so that one half of the figure matches the other half. In other words, if I can take a figure and cut it in half exactly down the middle and both sides would be exactly the same, or if I folded it over that halfway point and they match up exactly, then it has line symmetry. The lines that I can draw for places where I could fold that are lines of symmetry. So that's the difference between the two. If a figure has line symmetry, that means it matches up on both sides, and that actual line where that would be drawn is the line of symmetry that splits it in half. So if we take a look at example 1 here, it says, determine whether the sign at the right has line symmetry. If it does, draw the lines of symmetry on the figure. So, looking at this figure, it's a circle. Now, if I were to take what's on the inside of the circle out of there, and there is no drawing or symbol on the inside, the circle would have a whole bunch of lines of symmetry because I could fold it in all kinds of different places and it would match up on both sides because it's a perfect circle. What they've done here by putting this symbol in the middle makes it more complicated now, because instead of having an infinite number of lines of symmetry, this circle does have line symmetry, but it only has 2 lines of symmetry now. Because if there's something in the middle of the figure, there's some kind of picture inside, if I split that in half, in order for it to have symmetry, both sides have to match up exactly. So looking at this circle, then there are only 2 lines of symmetry that I can form, where if I folded this circle in half, that this symbol in the middle, this kind of rounded rectangle that's in the middle, would also match up on both sides, and here's where those would fall. I'm going to do my best to draw them nice and straight in the right spot here, but straight up and down through the middle like that. I could fold it over that line, take the right half and fold it over on top of the left half, and it would look exactly the same. It would match up. Or, see, and I didn't get that in the exact right spot. Let's see if I can get rid of that and do it again. I could fold it across the middle as long as my line went right through the middle of that rectangle. That's a little better. I could fold the top half down on top of the bottom half and still have that symbol in the middle match up. So yes, this figure has line symmetry because I can fold it in half to where both sides match up, and here is where those lines of symmetry would be. I can't make a diagonal one because what would happen is the rectangular shape in the middle would not match up on both sides, and it wouldn't look exactly the same. So I can't say that those are lines of symmetry of this figure because of the picture that's in the middle. If that picture was not there, I could draw a whole bunch of diagonal lines in this circle. So down at the bottom here, there's just some things to know. it says some figures have more than one line of symmetry. Some might only have one, and we'll run into some that only have one as well. And it's showing me right here, there's a pentagon that has 5 lines of symmetry. Now there's going to be a trick where if your figure has all of the sides that are the same size, the same length, like if you look at this pentagon right here, it has 5 sides that are all the same length, then your figure is going to have that many lines of symmetry. So because this pentagon's sides are all the same length, it has 5 lines of symmetry. If I have a triangle where all 3 sides are the same length, it would have 3 lines of symmetry. If I had a square, it would have 4 lines of symmetry. As long as all the sides are the same length, it has the same amount of lines of symmetry as it does sides. If you have a figure where not all the sides are the same length, they're different lengths, then you have to look at it a little closer to figure out how many times can I fold this to where it would match up on both sides, if any. Sometimes figures don't have any. Right here it says, notice that the arrow ends that are not labeled are the other ends of the arrows that are labeled. Meaning, when I'm looking at this pentagon, I don't count all of the arrows here, because each of the arrows that doesn't have a number next to it is just the other end of one of those lines. So I'm not counting the arrows around the outside, I'm counting how many times could I fold this figure in half to where it would match up on both sides. So what they did here with this pentagon is they said, okay, I could split it right down the middle there and it would match up. I could also, and if you notice, there's one that goes through each one of these corners and then it goes through the middle of the side that's across from it. So if I just did each of the corners, here's my next corner, it goes through the opposite side, this corner goes through that side, this corner goes through that side, and this corner goes through that side. I didn't get them exactly on there, but notice I only drew 5 lines, 1, 2, 3, 4, 5, so that pentagon has 5 lines of symmetry. And then there are some figures that do not have any lines of symmetry, like this trapezoid at the bottom. Because if I tried to split it in half and fold the top half down, then you'd end up with a weird spot sticking out on this side, and it wouldn't match up. If I tried to split it in half and fold the right half over the left, again, you'd have a weird corner sticking out over there. I couldn't do it diagonally because that doesn't match. And so this figure does not have any lines of symmetry. And we will run into some more that don't. So let's keep going and look at some more examples here. Example 2 on page 932 says, circle the figures that have line symmetry, and on those figures, draw all the lines of symmetry. So we've got all kinds of different figures and shapes here, and we first have to decide yes or no, do these figures have line symmetry? Is there at least one spot that I could fold this figure in half where both sides would match up exactly? So taking a look at these figures, a square we actually already mentioned, so I know, yes, a square has line symmetry. This next one is a 6-sided figure, which you might remember is a hexagon, and I'm noticing that all of the sides of this hexagon are the same length, so I know that, yes, this is going to have line symmetry. I'm taking a look at this triangle, and I know some triangles have line symmetry, But on this one, where I've got 3 sides that are 3 different lengths, and I'm kind of imagining trying to fold this in half and see if it would match up, I can't think of any spot where if I folded it that it would match up on both sides. So this triangle does not have line symmetry. And this heart does. There is at least one spot where I could fold that in half and both sides would match up. Now, going back for the second part of this, I guess we could finish part 1. It was the square, the hexagon, and the heart. So now I have to go back and draw the lines of symmetry. And so remember what I pointed out with the pentagon on the last page. When the sides are all the same length, I know I can send a line of symmetry through each of the corners. So if I did that on my square, I would end up with lines of symmetry that are diagonal, and that does work because all the sides are the same length. In a rectangle that's not a square, where you have 2 of the sides that are longer, a diagonal line of symmetry does not work. You just go ahead and try that. Get a rectangular piece of paper and try to fold it in half diagonally. It won't match up. It sounds strange, but because the sides are not the same length, it doesn't work. But when the sides are the same length, like they are in a square, it will. If you don't believe me, just get a piece of rectangular paper and try it. So I can send one through each of those corners as well. And then the unique thing about a square is, since all the sides are the same length, I could also split it this way in half and this way in half. So since it's a 4-sided figure where all the sides are the same length, it has 4 lines of symmetry. So we're going to end up with the same thing for the hexagon. It's a 6-sided figure where all 6 sides are the same length, so I should have 6 lines of symmetry. Let's see if we can find them all. So I could start with diagonals. I could go from this corner to this corner. I could do this corner to that corner. That's 2. I could go straight across from corner to corner. That's 3. Now, since these are all the same length, I can do the same thing I did with the square. I can go from the middle of the side straight across. And that's going to give me the other 3. So I could do this, 4. This side to this side would be 5. And this side to this side would be 6. The triangle has none. The heart, since it's got these rounded edges, only has 1. And that would be straight down the middle. If I tried to fold the top down, it wouldn't match up because it's got rounded edges on the top and it comes to a point at the bottom. So if we go on to the guided practice on the bottom, it's kind of the same steps as up top. Determine whether each of these figures has line symmetry, and if it does, draw the lines. So looking at number 1, I've got a trapezoid here, and I'm trying to imagine, is there any way I could fold that in half where both sides would match up? The answer is yes. There is one spot. We'll see if you are able to come up with it. If I go right down the middle there and folded that in half, both sides would match up. It's the only spot for this trapezoid, but it does have one line of symmetry. For number 2, we've got, let's see, how many sides are there here? 1, 2, 3, 4, 5, 6. This is a hexagon. It has 6 sides and 6 corners, but it's what we call an irregular hexagon. Not all the sides are the same length. It's not a nice and neat one like we had up top. And no matter how many different spots I try, there is nowhere on this figure where I could fold it in half that both sides would match up. This figure does not have line symmetry. Number 3, we've got a triangle, but it's a different kind of triangle than up top. Up top, we had a right triangle where all 3 sides are different lengths. Here we've got an acute triangle, and it looks to me like all 3 sides are the same length. So this triangle does have line symmetry, and since all 3 sides are the same length, I should be able to find 3 spots where I could fold it in half and have symmetry. And those 3 spots are going to go through my 3 corners. So I could go straight from the top down. I could go from this corner across. I didn't get it exactly in the corner, but I could go from that corner across as well. So that triangle has 3 lines of symmetry. If we go on to the next page, I've got the same thing. Determine whether each figure has line symmetry. Write yes or no, and then draw them. We've got in number 4, it's kind of a unique figure here. We've got a star, and in this star, all the sides are the same length. So yes, this does have line symmetry. Since, let's see, let's do it this way. For my lines of symmetry here, I can go from each corner. So, and it goes to the kind of indented corner that's straight across from it. So there's 1 right there, 2 right there, 3, 4, and 5. I didn't get them exactly in the right spot, but that figure has 5 lines of symmetry. Looking at number 5, I've got another trapezoid here, and with sides that are different lengths, and one of them's angled out. No matter how many times I try to fold this, both sides will never match up exactly. That does not have line symmetry. Number 6 is an interesting one. We've got kind of, it's almost like a rectangular shape, only 2 of the lines are curved. And right off the bat, looking at it initially, you might think, yes, if I folded this in half, left over right, it would match up. But notice what's happening here. On the top, on the left, the curve goes up, and then on the right it goes down. Same thing on the bottom there. So actually, if I tried to fold this in half, it would not match up. It would have to be curved like this in order for it to match up on both sides. So this does not have line symmetry. Number 7 is a different kind of trapezoid where I've got these 2 sides that are angling away from each other, kind of at the same direction. And so yes, this does have line symmetry because I could split it in half right there and both sides would match up. That's the only line of symmetry it has, but it does have symmetry. Number 8 through 13 asks us to circle the figures that have line symmetry and cross out the ones that do not. Number 8, we've got a trapezoid, and we've got different lengths of sides here. There's nowhere I could fold that to where both sides would match up. That trapezoid does not have line symmetry. Number 9, we've got an octagon here. It looks an awful lot like a stop sign, and all 8 sides are the same length. So yes, this should actually have 8 lines of symmetry. Number 10, we've got another right triangle here where we've got 3 different lengths of sides, and because those sides are 3 different lengths, this triangle does not have line symmetry. Number 11, we've got, what, 1, 2, 3, 4, 5, 6, a 7-sided figure. And we've got this one that's kind of at a weird, just very slight angle there. No matter how hard I tried, I won't be able to find a spot where I could fold that one that it would have symmetry. Number 12, we've got a triangle where it looks like two sides are the same length and then that bottom one's a little bit longer. Since two sides are the same length, this triangle does have one line of symmetry. I could split it right down the middle. And number 13, we've got, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-sided figure. Looks kind of like a fat cross almost. And you've got the sides that are across from each other, the opposite sides are the same length. And so this does have at least two spots where I could split it in half. I could go straight up and down and straight across the middle, and it would have at least two lines of symmetry. Number 14. They've got some lines drawn on some of these figures, and they want to know yes or no, is this a line of symmetry? To where if I folded it in half right at that line, would both sides match up? Well, number 14, we talked about rectangles a little bit ago on how if I try to fold them diagonally, it will not match up. So no, this is not a line of symmetry. Those sides would not match up. Number 15, we've got this trapezoid here, and they picked to go across these two angled sides, and because of that, if I tried to fold it in half right there, these corners would stick out from the other corners, so no, that would not be a line of symmetry. And for this pentagon, if I split it right down the middle there, yes, both sides would match up here, so that would be a line of symmetry. For the story problems on the next page, number 17 wants us to look at this yield sign. It says, Layla saw this sign on her way home from school, and it wants to know, does this sign have line symmetry, and explain. Don't be too quick to answer that question, because looking at that shape, I might automatically say, well, yeah, this is a triangle that has three sides that are all the same length. But we talked about this in the very first page. This part here in the middle matters. It comes into account. So if I tried to split this in half here, the letters that are on each side do not match. So because of that, this sign does not have line symmetry because the letters don't match. For number 18 and 19, it says draw the other half of each symmetrical shape. So they're telling me that I've got a half of a figure here, and this line is a line of symmetry, meaning that the other side of this figure should look exactly the same as this side. So I'll do my best to draw that with my pen here, but I want both sides to match up so that if I folded it in half, it would be symmetrical. So what I do is just continue this one across like this so that both sides look as close as you can to the same there. Not too bad on that one. So for this one then, I need it to come and curve this way just like that. And I have to see if I can get my arrow there. Not too bad. Number 20 says, draw an object that shows line symmetry and an object that does not. And draw the line of symmetry for the object that does have line symmetry. So here you can get kind of creative to where you could do, like we talked about on the first page, a circle has a whole bunch of lines of symmetry, but if you put a figure on the inside of it, like let's say I put a smiley face here, And we'll just pretend that both of my eyes are in the exact same spot. Now this circle only has one line of symmetry because of that smiley face. I could split it in half to where there's an eye on each side and half a smile on each side. But that's the only place I can split it because of the picture that's there. And for my object that does not have line symmetry, I can get all kinds of creative and come up with whatever kind of figure you want that is not symmetrical. Okay, let's skip over number 21 and look at what the homework page would like us to do. And it's on the bottom of the first page here, pretty similar to what we had in our example problems where I say yes or no, does this figure have line symmetry? And then if it does, draw the lines of symmetry that it has. And then on the back side, they have a figure where they've drawn a line in for you, and you just have to say yes or no, is this a line of symmetry? If I folded this in half, would the halves match up? Number 7 and 8 are what we just did on the back side of that other page. You have to draw the other half of each symmetrical shape. Now, be careful with number 7, because I remember from years past I have had several people do this and just turn that into a triangle. Well, if that's the case, then that is not a line of symmetry. So figure out, if this is supposed to be a line of symmetry, what should that other side look like? Same thing for number 8. Number 9, we had a question similar to this a few assignments ago about parallel and perpendicular lines. You've got Vince writing all the capital letters of the alphabet, so if you need to write them all out to look at them, go ahead and do that. Wants to know which of the letters have more than one line of symmetry. So don't write down all of them that have symmetry, only the ones that have more than one line of symmetry. I'll give you a hint, there are 4 of them. See if you can find all 4. Then 10 and 11.